Hello everyone, and welcome to a quick tutorial on how to perform a transient analysis using the MV-x as a data collector. Keep in mind that this process is not supported by ACOEM anymore, so if you have any problem, any questions, they might not be able to help you out. So yeah, keep that in mind when you try it. The first thing to do is to create a machine that will allow you to monitor or to capture a time waveform of the full run-up or the full coast down of your machine. I will show you my quick setup that I did for my bench. So I can go and set up machine here, and I can open the one that I already did. So you name it the way you want it. If you go in schematic, you drag and drop the machine that you want, you activate the position where your sensor will be placed. Mine are all vertical on the 4 point of my system. My machine has to be set into a variable speed, so I can trigger an acquisition when it sees the machine starting up. And this is done in the strategy. So you can set up your rotating speed from 0.2 Hertz up to 25 Hertz, depending on your machine running speed. And my operating condition is set up to store the data on condition, meaning that when it will see the 0.2 Hertz, it will start the acquisition. You can put that to 0.05 Hertz or put it in RPM, it doesn't really matter. It's just that it will automatically acquire the data without you pressing anything. You can also do it manually, but this is a better way to do it in my mind. Alright, in the measurement tab, you need to create a time waveform for each of your bearing, each of your sensor. My time waveform is a 32-second time waveform. So I'm using a 512 Hertz sampling rate that will give me an Fmax of 200 Hertz. On this particular test, that's more than enough. It's more than 4 harmonics of my running speed, so I'll be more than happy with that. You also need to configure a time waveform of your tachometer. So you need to simultaneously acquire the tachometer signal as well as the signal from the bearings. To do that, you need to create a process group, AC, and in the input type you put tachometer, and you set up your trigger threshold, so low and high trigger threshold. Mine is a 5-volt tachometer, so my trigger threshold is 4 and 3. I can show you very quickly what it looks like if you never saw one. But my trigger signal looks like this. If I zoom in, you can see that it's a pulse, and it goes up to 4 volts. So when it sees a 4 volt and a 3, it means that it counted 1 pulse, and this is the way that the system knows that it saw a tape, it saw a reflective tape, so 1 impulse per rotation. And yeah, this is how you configure a tachometer. So here my process group named temporel, my I trigger is when it sees 4 volt and 3 volt and 1 pulse per turn. You could have more than 1 pulse per turn, doesn't really matter. Yeah, so process group 1, and I need to add a treatment to that process group time signal, and you program that time signal to be the same parameter as the one on your bearing. So on here you have a high pass filter. I don't have any high pass filter, same sampling frequency, same number of sample, 32 second, that should work fine. After that, you need to connect your parameters, your data acquisition parameter to each channel. I cannot show that here because my MV-x is no longer connected to that server, but it's the same as usual. You need to pair each channel with each sensor. And for the tachometer, you need to click the rotational speed on that channel, and as well the temporel here. That's my process group name. So I need to put these two on the same channel, and you would be good to go. So you would hit save and start the acquisition, and when the system would see the motor turning, it will take the acquisition. Alright, the acquisition is done. If I go now in my analyst module and in my run up close down bench, I will have date and all that, but also I will also have my data for each of my sensors. So here you can see I have a 32-second time waveform of my run up. I have this for each channel. And I also have the same for the tachometer. This is a clean, nice and clean signal that you can very easily check the speed of, 26.4 Hertz. So that's very good. The next step in the test is to select all the points. So I select my 4 sensor and my tachometer, and you click the overlay. How do you call it? I call it the overlay, but it's a superpose plot, and that will put all the plot one over the other. So here you can see that I have my tachometer signal and my 4 signal one above the other in that screen. The next step is to open your VibGraph here and create, and I cannot show that, but you need to create a session by clicking File and Create Session. Sorry, it has a little bug, so I cannot show it on a second screen. So let me create a quick session here. So once you created a session, so File, Create New Session, save that file somewhere, you will get this window that will show. Click on your time signal, click on File, and you cannot see it here, but you have an option that says Save on Current Session, and you can see that all my file went into my one single signal window here. And what's very important, it's 2 things. So you can see here the unit its voltage for the process, which is my tachometer. And the time is exactly the same. So the measurement time, it's the same thing. All right, the next step is to select your tachometer, click on Additional Information, and change your type of measurement to tachometer. And click Back Up and Quit. So now the system knows that this signal is a trigger instead of just a time waveform or normal time waveform. The next step is to select one of your time waveform, your normal bearing, and click Shift and select at the same time the trigger. And you will need to get from your ACOEM representative or from the support, or normally you get that from the support, a VibGraph Expert license that will unlock that processing function. So once you have that, you can click on processing, and then when you have 2 signal like time and trigger selected, you can select the transient analysis feature. And to change the setup of that feature, you need to select it first here and then click on the little screwdriver. And once you click on the screwdriver, you have here, let me start by scratch, you have here phase and order extraction. So you select that, you put it on the right side, you edit that. You can change the name here to transient. It doesn't It doesn't require that, but it makes it more easy to follow. And the next step is to set up your extraction, not peak, but phase and spectrum extraction. So my detection threshold for my tachometer, let me put 3.5 volt, and my load threshold will be 2.5 volt. So this is how it will detect my RPM. I will select the phase extraction and signal segment. Leave the hold-off delay by 80%, that's fine. The averaging 1 is fine. My slope definition of my tachometer wasn't the positive sign, but if you're using a key phaser, you might get negative slope for your signal. Here you can ask the system to give you a FFT every 10 RPM, between 20 RPM and I think it's 1800 RPM in my system. So every 20 RPM it will calculate an FFT. It's a run up, another coast down. Block, you can put it at start. My bandwidth will be 200 Hertz, and I will ask for a 200 line FFT for each of the FFT, and click OK. And once this is done, you click OK, and now you can process that. So by clicking the red record button, it will calculate that run up or coast down. And now if I select my waterfall, so I select here at the bottom waterfall, click on that little guy, I now have a waterfall of my measurement. You can also select the Bode, so you don't see it on the side, but Bode diagram, and that will give you a Bode diagram of your reading. You can see that this reading doesn't have maybe not enough measurement, or so what I can do, this one has 52 separate spectrum. If I want, I can go back to the processing and change a little bit of my settings, calculate that, and now I have 104 and more line of resolution, and now it's more cleaner. So if I open a Bode, yeah, this one has too many lines of resolution, so let me go back. Well, you can play with it very easily. That's the beauty of the system, of using this, I mean. Bode, here. There you go. So if I go in that area, I can calculate, I can check if there's a 180-degree shift somewhere in there, and see if it's one of my mode. And that's it. This is how you can recalculate the transient analysis from time waveform reading, and that will work for the MV-x, the Falcon, and anything that has synchronous acquisition.